Okay, let's begin with question number 10. Okay, on this paper, so I'm just going to move it to a whiteboard. And we're going to begin with that. So the equation of the curve is given like this. Okay, so y is given as 5x plus 4 to the power of half. Square root is power of half. It's actually that. It's a printing normal. Okay, so calculate the gradient of the curve at the point when x equals to 1. Okay, so we need to do a bit of a chain rule. If it helps, some people will do like this. I'll just show that. They'll put u to the power of half, and then they'll let u equals to the thing inside the bracket, 5x plus 4. It's not necessary if you can do it without writing this. But if it helps, you can also use slowly like this. So dy du will be half, just differentiate with respect to u. So half minus 1 like that. So it becomes 1 over 2 root of u, because negative half is down there. Then if you want to put it back, the u itself, so 1 over 2 root of 5x plus 4. So similarly, just beside it, I'm going to do the differentiate this side. So whenever you write a substitution, these techniques, just differentiate whatever you get first. So this is 5. And then we link the thing. Please take note. So link means it's the chain rule. Okay, it's called the chain rule. So under the chain rule, what we do is dy dx is equals to dy, the intermediate variable. Okay, I'm just going to write like this so that it's easy to see that this is like something like the u introduced. Think of it like a fraction can cut like that. It's not that, okay, technically, but the notation is just a coincidence. So we can view it like that for simplicity. And the dy du part, if you look at it, it comes from this section. So I'm going to copy this and write it here. Let's take note. So root of 5x plus 4. And then times with, what is du dx? We take this number. It's just a constant, 5. Oh, that means dy dx is, ta-da! Okay, 5 over 2 root of 5x plus 4. So some people, how they do, without doing this in one go, what they say is, you can also do that way if you are proficient in it, times the half in front. You minus 1, so imagine become negative half, so square root underneath. So that means the 5 is settled, and the square root underneath makes these two terms. And then you differentiate inside. Differentiate inside, you get 5. You divide, differentiate inside, you multiply by that. Okay. So times the half becomes that, times the 5. Sorry, too wrong this now. Okay. So it becomes, what is the word? 5 there. So that's how we do this. But they say evaluate it at a point where x equals to 1. So when you go to uni or college, they sometimes use this notation. They put x equal to 1 with that. Also, sometimes there's another notation they use. Or you can just say x equal to 1 and calculate. Maybe in other places they use it as well earlier. So put x equals to 1. Let's just calculate it. Let's see. So 2 root of 9. So when the square root exists in the question, we take it as a positive root. And therefore, this just reduces to 5 over 2 times 3, or positive. And the answer is 5 over 6 for this part. Okay, let's take note. It's 5 over 6. Huh? Aha. Okay, so I'm going to clear this. I'm just going to write 5 over 6 up here for this part. And then let's go for the second part. Perhaps it is linked means. They won't tell, so we have to read and see. So a point with coordinates x, y moves along the curve in such a way that the rate of increase, the rate means dt, of x means dx dt. Okay, that's how we read this. Good thing that the math vocabulary is pretty easy to catch because they use almost the same thing all the time. So dx dt has the constant value of 0.03 units per second. Constant is good because it doesn't depend on the value of x, but where x is on the curve, this is the rate in which it moves. So find the rate of increase. That means find which one? dy dt now at the instant when x equals to 1. See, the x equals to 1 part, students sometimes get confused. Never substitute in between. This is always the final step. So what we need to do now is we need to do a chain rule. So let's take a look at the chain rule idea, please. So you want to find dy dt. So what you do is you write that thing that you want, dy dt like that. Then think of it like a fraction. It's just a way of thought. It's not a real fraction. Remember the earlier part I mentioned. Then you just write the only other letter that exists here. If there are more letters, you can write chain rule. Actually, it can go on like that. I have seen some questions like that, but they are a bit rare. Okay. So dx like that. Aha. So dy dx. So it's kind of like, oh, the dy dx is just copy. I realize that dx dt, no matter what, is always going to be 0.03. The dy dx is what we found earlier. But the good news is they want to evaluate it at x equal to 1. So that means this one I just need to evaluate it at x equal to 1. So it's a nice shortcut. If you notice that, that number is just the answer for the earlier part. So it's just 5/6 multiplied by 0.03. So the answer will be, I'm going to calculator, please. 5/6 times 0.03. Aha, 0.025. Either you can write like that, or you can just write 1/40. So the increase is 0. Preferably decimal if they gave the other one in decimal. Unit per second. Positive means it's increasing likewise. Okay. Okay, now let's do the third part. Aha. So the third part is completely unrelated to all this because they're talking about the area enclosed by the curve x-axis, y-axis, and the line x equal to 1. The marks is a bit higher. Okay, so if you look at it, they didn't give a sketch of the curve. Do we really need to know the sketch of the curve? Depends. Okay, it depends on the curve. Because sometimes some kind of blip inside, like cuts out and down like that and all that, a few rounds there, the area can change. But in this case, I don't see that happening because an increasing curve, square root function, x increase, y increase, inside out plus, nothing, just okay. So that means, aha. So what I need to do is I always want to see where it cuts the curve first, the intercepts, okay? Because they already say about the x equals to 1. So the intercepts are to help us understand where it cuts the x and the y-axis. Okay, so let's take a look at it, please. So the intercept, when x equals to 0, the coordinate will be 0, 5 times 0 plus 4, the original. So this becomes root 4, positive 2. Okay, so we have a coordinate here, which is 0, 2. Okay, 0, 2 like that. And then just to check, good to put y equal to 0 and check if can, the curve equation is easy. Sometimes not necessary. We just want to show or demonstrate that. So we can increase the understanding. We put 0 like that. We solve for the value of x. So 5x plus 4 is 0. X is negative 4/5. Okay, which is negative 0.8. Okay, x is negative 0.8, from which we get the coordinate negative 0.80. So if you look at the negative 0.8 and 0, this way it's a bit the difficult part. Okay, it's on this side. It's somewhere here. This is the negative 0.8. 0 means on the axis. So the curve is cutting like that. And then up here, we just try to put the points. I want to put one more point on the calculate, if you don't mind. Sometimes we don't need all those lot of points, but just to understand the behavior of the curve. Okay, x equals to 1, y equals to root of 5, 1 plus 4. So they had a nice number there, root of 9, which is positive 3. So from which we get the third coordinate on the point of the curve, on this curve, which is 1, 3. Why am I finding this x equal to 1? Because of this thing. So the three things they talked about, now we're going to see where the coordinates are accordingly. So 0, 2 is up here, somewhere here, I guess. Ta-da, maybe somewhere up here. So you can see that it's increasing. That means maybe I'll sketch it first. Something a little easier. Aha. So we have this is the 0, 2 part. So I just put a 2 here because 0 is readily seen. Oh, that means this part. Now I just need to draw a line. Ta-da-da. Okay, let's cut the cross width line. X equals to 1. And then I'm just going to label the coordinate part. So this is 1, 3. So if it is 1, 3, this will be 1. This will be 3. Aha, 1, 3. And the blue curve is the curve that we're talking about. So root of 5x plus 4. It's not necessary to do this sketch, but it's helpful. Okay, it's helpful. And the area bounded by, now we can see visually. Sorry about the extra little bit there. Okay, I should be more careful with my shading. Yeah, sorry, down here. So okay, inside this. So this is the area they're talking about. So it's pretty obvious there's no tricks and all those funny things I was telling or contemplating that it might happen. That means like, all those like wiggle inside there, come in like that or what. And then we have to see the negative and positive area and do all those things. Okay, but it's not that case. So it became way easier, hopefully. So therefore, the area of the ping area, 0 to 1. So they didn't tell that. If you notice carefully, they didn't give the boundary of the area. So you must understand this from 0 to 1, y dx. Oh, so area under the curve, 0 to 1, 5x plus 4, half dx. So we already did this calculation earlier. Either you can take the earlier one or do it again. So half. So 1 times it from inside. So it was 5x plus 4. Sorry, what am I writing? Okay, silly me. Okay, so when you put this bracket first, so 5 over times the half in front, so like that. So 5x plus 4 minus 1 is the power is square root there, down there, or half like that. So the limits are 1 and 0, 0 to 1 actually, okay? So let's substitute and calculate that please. So when you put the value of 1, it becomes, okay. So the constant like 5 over 2, all right, you can just bring it out like this, 5 over 2. So we're substituting the entire thing as though like 5x plus 4, square root or half like that, this is half, and then 1, 0 and 1 like that. These are like equivalent, just mentioning. So 5 over 2 bracket, let's write in minus the thing. Okay, so 1 over, put a 1 there. Become 5 plus 4, square root like that, minus 1 over, put the 0 there. 5 times 0, 0 plus 4 like that, square root. Oh, so it becomes clearer that these are special numbers. So a bit easier to calculate, which is good. So these are definite integrals with it. So there's no constant because the constant cancels out. Okay, so 5 over 2, this is 1 over root 9. I do here because it's spacing. 1 over root 9 like that, minus 1 over root 4 will actually become 1 over 3 minus 1 over 2. And what is 1 over 3 minus 1 over 2? Should be 1 over 6, right? Yeah, double checking. Negative 1 over 6. So negative 1 over 6. Yeah, clean correctly everything. 3 minus negative 1 over 6. So 1 over 6 lah, because we take the area. What is it? 1 over 6. I'm wondering why it's negative. Should be positive, right? Of the axis actually. Did I do the times all correct? Correct, huh? Perhaps it's like that. Okay. So let's just calculate it. So when it times it, it becomes 5 over 12, I guess. So the answer is 5 over 12, if I'm correct. I'm still wondering about the negative part. Did I do the times all correct? Minus half times in front. Sometimes some blunder here and there. Yeah. I went and substituted wrongly, I think. Oh, sorry, I made a mistake. I know what's a mistake. No wonder the negative shouldn't be an area. It's a good joke, actually. I went and differentiated instead of integrating. Okay, sorry. All right, because we made a mistake, so now we can correct it. Ta-da-da! It's the integration, not the differentiation. Somehow mine got mixed up in two. When this part is wrong, let's correct that, please. Aha. So with the integration, this is not the formula. So when we integrate, not differentiate, the early one is differentiation. I got tricked myself. Okay, let's do that properly. So that means when you integrate this, you plus 1. So it's like in reverse. So when you plus 1, this becomes 5x plus 4. The power plus 1 is 3 over 2 half plus 1. Then this number, normally we multiply it, so now we divide. So it becomes 2 over 3 like that. When you divide, it becomes upside down. Divide by 3 over 2 is times by 2 over 3. And then usually what we do, we also multiply by the differentiating side. So now the opposite is divide by 5. So in other words, we need to evaluate this. So 2 over 15, the constant taken out from here to here. This is 1 and 0. All right, let's try to complete that. So 5x plus 4, power of 3 over 2. Well, that's it, because I brought out the constant. So when you substitute that, so now this becomes just evaluating 2 over 15. Let's put a 1 please. So the 1 becomes 5 plus 4. This x is 1, so 3 over 2 minus 0 plus 4, power of 3 over 2. Okay, the difference of that, definite integral, so no constants. All right, let's repair that. So 2 over 15, this becomes 9 over 2. That means I do up here as before to see the numbers. Ta-da. So 9 to the power of 3 over 2 minus 4 to the power of 3 over 2. You can either use a calculator or you can do it by hand like this. So root of 9 half is 3. So 3 to the power of 3. 4 half is 2 to the power of 3. So 27 minus 8. Aha, what is 27 minus 8, which is 19. So this is how I'm getting the 19 here in the subtract. So 19 times 2 over 15, ta-da, is 38 over 15. So that's the answer. We don't need to simplify, right? That one they don't really bother. Okay, just levels, so just can accept like that.